In this video, we'll continue our discussion of limiting and excess reagents. In the last video, we discussed how to calculate the amount of product that will be formed when the mass of two reactants were given and one of them is limiting, meaning that one of them will run out first, and then you have the other reactant that is called an excess. So in this video, we are going to calculate the amount of the excess reagents. We're going to focus on the excess reagents here, specifically the amount of excess reagent that is left at the end of a reaction. So we're talking about the end of a reaction, assuming, because we have already talked about yield a little bit, assuming that we have 100% yield. Okay, so these questions really doesn't have to do anything with yield yet. We're just assuming that we have 100% yield. And then if we say the end of a reaction, by that we mean that it's the point where your limiting reagent runs out. So we'll define the end of a reaction, okay, as when your limiting reagents runs out, okay, assuming 100% yield. So then I'm going to refer to the question that we did in the last video, where you react chloride dioxide with water to form chloric acid and hydrochloric acid. And when you balance it, the coefficients are 6, 3, 5, and 1. So an overview of what we did in the last video, we were given the mass of each reactant. But again, mass it's not a good indicator of which one will run out first until you convert it into moles of each reactant. And then we determined which one the limiting reagent is by looking at the amount of product that each of them allows us to make or to produce. So we found out that chlorine dichloride allows us to make the least amount of product, which tells us that this is our limiting reagent. And so this is the amount of product that will actually be formed, assuming 100% yield. In question B, we then multiplied by the mass of this product. So we have 0.8759 moles. We multiplied it by the molar mass of the product, which is 84.456, to get 74.05 grams. So that tells us how much products can be made by mass, the mass of the product that can be made. So then the next question is, at this point where the reaction is done, we took all the reactants we have. In fact, we took the limiting reagent, and we're saying that at the point that the limiting reagent runs out, the reaction cannot continue, right? You're done the reaction. You have no more of this. You cannot carry out the reaction any further to make your products. So at that point, what mass in grams of the excess reactant remains at the end of the reaction? So I want to point out that if you look at the amount of moles we have of each reaction here, they actually look very, very close. 1.051 moles of chlorine dioxide, 1.056 moles of water. And in fact, if you kind of discard the mole ratios, right, some people will have this misconception where, oh, we have less moles of this reactant, it must be the limiting reagents. In this example, it happens to be, but then you really have to look at the mole ratio. You can not just say, oh, this is less, therefore we're going to use this up first. You also have to look at the fact that in the reaction, we use 6 molecules of chlorine dioxide every time we use 3 water molecules. So you're using this chlorine dioxide, this reactant, twice as quickly as you're using up water. Right? So let's say you have equal amount of moles of both. Even so, this will run out faster because you're using this at a faster rate. In fact, 6/3, twice as fast as you're using up water. Right? So then, if you look at these, well, they're almost the same amount of moles, except you have to use this up twice as fast, which tells you that even if I don't calculate this, I can tell that this will run out first. Right? In reality, if you're using 1.051 moles of chlorine dioxide, you can only use half as much as water. Or if you want to take this amount of water and react all of it, you need twice as many moles of water so that you can react with all the water. But anyways, we already calculated and we know that this is our limiting reagent. So now we're going to focus on the excess reagent and how much of that will be left at the end of the reaction. So what I've done is I've copied the equation down, I've copied the amount of moles we calculated in the previous reaction, okay, because the mass is not needed, and I've written down that chlorine dioxide, which makes the least amount of product, is our limiting reagent, and then water is our excess reagent. So these numbers are recalculated. These are moles of each reactant that was available to us at the beginning of a reaction. Okay, so right at the start of reaction, before they were mixed together, even, okay, before they reacted together to make products, this is how much you have of each reactant. And so also a reminder that if we were to plan this, when they say a leftover, our excess was water, leftover water, we'll calculate in moles. Okay, so moles of leftover water. How we calculate for leftover is if we take the moles that were initially given to us, so available at the beginning of a reaction, and we subtract the amount of moles that was used during the reaction, then you have left over. So the number right here is the number available to us at the beginning of the reaction. So in this equation, we have 1.056 moles available to us in the beginning of the reaction. Question is, how many moles did we use? Well, how many moles we used depends on the amount of limiting reagent. Because remember, at the end of the reaction, when your limiting reagent runs out, that's when you stop everything, which means that's the point when you stop using the excess reagent. So that depends on the amount of limiting reagent. So we have to use the information from the limiting reagent, and we say that at the time that this is all used up, how much of the excess have we used by then? Whoops, that should be 3/6. Sorry guys. So this mole ratio tells us that at the same time that you have used all of this, you would have used half that amount. So we can use a mole ratio not only to calculate the amount of products that you can make, but also to calculate how much of the other reactant you have used. So again, this sounds very repetitive, but what we have done is this. We have said that out of 1.056 moles of water available to us at the beginning of the reaction, at the end of the reaction when this runs out, when our chlorine dioxide runs out, we have only used 0.5255 moles of water. So I'm going to put that down in writing. So by out of the 1.056 moles of water available to us at the beginning of a reaction, we have used, or we would have used, 0.5255 moles of it by the end of the reaction when our limiting runs out. Which makes sense. The fact that it's an excess tells us that there will be leftover. So in this case, how much leftover there is exactly? Well, let's subtract. So 1.056 minus 0.5255 gives us 0.5305 moles, again, of water left over. But the question asks for mass, so we can take 0.5305 moles of water times the molar mass of water, which is 18 grams per mole, equals 9.55 grams. Therefore, 9.55 grams of water remains at the end of the reaction. So again, looking back at what we did, we started by defining the what end of the reaction means, and in this case, if we assume 100% yield, again, if the question doesn't say, you always assume 100% yield. We define that as when the limiting reagent runs out in a reaction, because that's when you have to stop. You don't have enough reactants to go on. And then we looked at the moles available to us, and then we took the limiting. Using mole ratio, we calculated the amount of moles of excess we would have used by the end of the reaction, which is in this case half as much. Then we subtracted the two numbers, the moles available to us at the beginning of the reaction minus the amount of moles used, and that's the amount of moles left over. We then multiplied by the molar mass of the excess reagent, which is water, to get the mass of the excess reagent that's left over at the end of the reaction.